Honestly, it's crazy to be here at DevOps Warsaw. A few years ago, we couldn't imagine to give a talk at the DevOps conference. Julci used to be a researcher at the computer science department of Academy of Sciences in Hungary. I was doing a research in human-computer interaction. So that was kind of a long journey to arrive to DevOps from there. And what happened? We joined Prezi, and if you join, we joined Prezi as data scientists. It's very sexy, we wanted to do like data science. And we joined Prezi, and if you join a company that's small and it has a little data, let's say like a few gigabytes or maximum 100 gigabytes of data, then it's easy. Then you can just go on and do data mining, do analytics. But as the company scales, and right now Prezi is around 250 people, and we have around a petabyte of data, and that's a petabyte of data. It's a lot. And the team is Julci and me and another guy. So the data services team is still 3 people. So we would like to convince you here that if you are in an organization and you work with data guys, convince them to become proper DevOps, because it's not a data science job they need to do, it's a DevOps job. And this is what we will talk about. So, what is Prezi? Prezi is this presentation software. Have you ever used it? Can you raise your hand if you used it? Oh, that's quite a lot of people. Yeah, that's great. Yeah, so this is Prezi. We have somewhat more than 50 million users. We are approaching a petabyte of clickstream data, and clickstream data we mean log data when it comes how people, like how you behave on a Prezi website or anything. We have a nice office in Budapest and we have an office in San Francisco. But most of the engineering is done in Budapest. Yeah, so that's it. And this is the history on how we scaled data without scaling the data team at Prezi. So let's start. We started, the data team started around 2011, and what do you want to do if you set up a data team? Of course, you want to build a data warehouse. It's fancy. You can talk to consultants. They will give you very high prices. They can deliver you a pilot in half a year or something, which we didn't want to do. So there was a startup at that time. It was called, it's still on. It's called Good Data. It's a Czech startup, and they promise a data warehouse in the cloud. So you just push your CSVs and you can immediately create reports and all what you want to do with data. So it's very great because we could start creating a data warehouse on that day when we had the idea to create a data warehouse. And if you have a data warehouse and a reporting system, you need an ETL system. The ETL system is a data warehousing term. ETL is extract, transform, and load. So you extract the data from Google Analytics, the database, logs, or anything. Then you transform it so it makes some sense. Then you push it into the reporting system or anywhere. So you can actually use it. So we needed an ETL system. There are a lot of proprietary and open source ETL systems on the internet. And then but we decided to just create our own. This was it. And it's open source in this Prezi, because that was it. And it could do 3 things, like load how many Prezis we have, how many users we have, and how many cache we have. This is all it could do. It was written in Bash. We didn't know that time that Bash is that dangerous as today, so we decided. Yeah, and then we just started using Good Data. So you get your data, you put it in there, you create some metrics here, then you can create your charts and you can create your dashboard. It's very easy. And everyone got really happy, and the whole data thing just started to boom at Prezi, because we created the basic metrics, and then people, for example, the people doing QA came to us and they said, hey, we've seen your fancy charts and we want you to create some charts for us, like number of regressions and stuff like that. So we did it for them. And after a while we realized that we just cannot scale this, like we cannot create reports to anyone. So what we learned is that if you want to scale out data infrastructure, then you need to do it in a self-service manner. So then it started to go kind of a bit of DevOps, because it was like we need to enable these people to create their own reports. So this is what we did, and this is what we call like the ETL, the first ETL. It's Bash as a service, because at that time in Prezi everyone could do at least a little bit of Bash. So I will show you how, and hopefully you will see. This is how you could create a job in Prezi in ETL 1. So you wanted, for example, to extract the number of forgotten passwords. And we had some simple wrappers like getting from the Prezi log all the numbers, just grabbing for forgotten passwords. Let's see what's going here. We could format the date, you could cut and unique and do all this stuff, and you could fire out awk. And then you get kind of a CSV. We had some hashing program for creating a hash, and you could add the header, which is like echo in the beginning. And then we said to people, hey, this is very cool. You can create a CSV. And yeah, this is here one. So, and then we wrapped good data because it has some ugly XML interface, but you could just do like free word stuff, create a data set in good data, forgotten passwords, it has an ID, it has a date, it has some number we will attach, and this is the CSV. And then we had also some wrappers to create all this thing in good data, and you could load your CSV. Boom, then it's in good data. And then you could schedule it. And scheduling it meant that you just needed to create a file and replace the dates with two parameters, like the date in the beginning and date in the end, and the ETL system passed those two parameters to your script. And basically you were done. You created a schedule. You had to symlink it somewhere, and that was a big, like, some people failed on that because, you know, it's basic Unix is not symlinking stuff. So then you just committed it, and yeah, and boom, you got the chart. This is good data. You create a metric. For example, the sum of forgotten passwords. It will be here somewhere. Yes. You add it, and you said, okay, I want to break it down by the date. Yeah, break it down by the date and create a chart, not a table, and then it's done. So it was really a great success. People started using data, and we created kind of a self-service infrastructure for them. Even they had to do Linux a lot to get there. But it was a boom in Prezi. So what happened then? We had a lot more and more users, and we did some more and more developments. But the problem that we faced were that we got all the emails if the job of the people failed. And then we checked like what went wrong, and we went to the guy, hey, what's the problem? Here is how you can fix it. And then we realized we cannot scale, and we cannot just scan 20 jobs each day which were faulty. So we realized we need to create like a full self-service system for them. And this is what we did. This system, which we call like the old ETL now, it's still working, it's legacy, we want to get rid of it. It's not that easy. It's still some bash script that you create, but the main point is that it has an owner. So you say, I'm the owner of this script, and then if anything fails in the night, then you will be notified about what was the problem. And surprise, surprise, after 1 week of introducing this ETL stuff, all of the jobs got fixed because people got annoyed by the emails the system sends them. So yeah, let's just do it self-service. And this is already something like data infrastructure as a service, so we didn't care what people do, we just gave them the platform. Right now, this has around 400 jobs running a day, and we have now, Yuli will talk about another system that has also a few hundred. And we have 60 people from Prezi contributing jobs. Okay, so what's the problem here? It was still in Bash, it ran on one server, it started to run, it was no parallelization, so it ran like for 16 hours, and it's a daily ETL, so if we reach like 24 hours, then we are screwed big time. So we had to scale. So what do you do if you want to scale and you have at least some money? Of course, you don't want to be smart, at least in 2012, you just go for Hadoop. Because Hadoop is, and at least it was like the big promise of scaling. So we went and did some Hadoop. Hadoop is beautiful as long as you don't check out the tutorial. And the tutorial says that if you want to count how many words there are in a file, that's all you need to write. So simple, perfect solution. But it scales. And it has some wrappers. So there is something called pig. It's somewhat similar and the opposite of SQL, but you can use it on Hadoop. So you just write pig job like you wrote SQL on text files, and it will do all the dirty job in the background, and you can do data mining in a distributed manner. So we introduced pig, and that was a big success. So we could also scale in a data way. And what did we learn? That it was an on-premise Hadoop, and it just works as long as you don't go through like 5 nodes, because then you're through like 5 computers and then 10 computers and then 15 computers, it becomes a hell. At least if you're not a hardcore sysadmin, which we weren't. So I personally spent around 6 months of my working at Prezi, like keeping Hadoop alive, or at least on its knees. So that was pretty much of a roadblock. And we became proper sysadmins at the end, of course. So then we decided to move everything out. We didn't want to operate Hadoop. We talked to people to companies who give Hadoop support, but we were like, we don't need support. We want this whole stuff just running. So we went to Elastic MapReduce is Amazon's hosted Hadoop solution. It's great because it's managed, and Amazon does a very good thing in managing it. So it just runs. And it's elastic, you pay by the hour, you know how it works. And then you can just scale up Hadoop with another 100 computers for a few hours if you need some computation heavy stuff, and then just come back. And of course it has S3, which is infinite and very cheap storage. That's the good part. The bad part is that S3 compared to the Hadoop file system is very, very slow, especially if you work with a lot of small files. But we had to live with it. And also we cannot use high-end technologies because Amazon kind of tailors all the technologies before releasing it. So we have to wait. But it was a great success. Also today we have much more than 1,000 jobs running on a Hadoop cluster each day, and we have no idea, like the data team has no idea what those jobs are because we provide this whole stuff as an infrastructure. But at that time, we still thought that we are like data guys, not software engineers or DevOps guys. So then we said, okay, let's just do something big. And the big thing was, we called it data pipe. It was like a Skynet. It was a super intelligent ETL system. It knew its internal state. It had some DSS included, and we wrote it in Haskell because that's how like real men do stuff. And yeah, so it was super intelligent, like this guy here. But what's the other side of the story? Like usually with these figures, is just that no one likes them. So it's a self-service stuff. We need people who actually use our infrastructure. So one time, one of our early adopters came by and said, hey, I want to do some very wicked stuff in the ETL with job dependencies and all these things. And we were like, sure, just go ahead. It's like a 10-liner in Haskell. You write a module, come back. And then we saw his commit in the old Bash ETL system. So they just didn't use it. It's like if Chef was in Haskell, we would like never use Chef. Yeah, so we pulled back this whole project because we realized that we still have a lot of problems even without it. And oh yeah, that's the lesson. what I told you is that if you do self-service, you need some technology compatibility because no one will learn Haskell.
Okay, so after this failure, we dropped DataPipe and we went back to the old ETL. And we thought that it will be very nice, we have time to write tools for our users, it will be great, but we were always blocked by problems that came up time to time. Like, as Zoltan mentioned, we had this daily batch execution. So every morning we woke up and we opened our email with shaking hands and we hoped that no failing jobs email are there. But unfortunately it happened several times. And all the time when it happened, it took almost a day for us to recover from this problem because there was no dependency, no explicit dependency between the jobs. So we had to grab somehow the data sets, what is the output of one job that is used by another job as an input. So it was really painful. And it happened several times because like there was some bugs in our infrastructure and things like that. And it was very hard to find the root cause. So we introduced something that Prezi already had for the product. It's called Prio 1. So in the main product, so in the presentation tool, if a presentation is not available or the content changed, then it's a very important situation and all the developers stop on working whatever they do and they fix it. And that's what we did with data. So whenever we had some problems with the infrastructure, we stopped what we were doing and tried to fix it first. Then we wrote a document that we called postmortem, and here we investigate the whole timeline of the events, and we find the root cause. We brainstorm about how to avoid situations like this next time. And then we add action items to our Kanban board and things like that. And it worked very well because in less than 2 months we could fix the biggest issues that we had. And we never really knew that we have these issues. And our mornings are much happier since then. Yes, and there was another problem. This might be a bit funny for you. But we didn't really have monitoring like half a year ago. Or there was some basic alerting. First there was no alerting, and our alerter was the head of finance because sometimes he wrote an email that, hey guys, the numbers don't match with the bank account and there must be something problem. And then it took a lot of time to investigate at which point in the chain of jobs failed something or went wrong. So first we had a very simple alerting tool. It was a Python script. You could add modules, and then if one check failed, then you got an email. But after a while, one little problem triggered hundreds of emails because we had so many checks for everything. And then our inbox looked like this. So it was very noisy, and we got alerter fatigue, so we couldn't really focus on the problem because we didn't really knew what the problem was. So then we went to the real DevOps guys in Prezi, and they helped us to set up an iSinga, and now we are much happier. So if something goes wrong, we get exactly one email, and we have a nice dashboard next to our desks, and we can look at it, and if something is red, then we are unhappy, but otherwise everything is okay. And yes, with time, Bash became a big drawback because a few years ago, almost everyone was a developer in Prezi, and we could tell them that, okay, write a big script and wrap it into a Bash job, and it worked. But lately, a lot of analysts and marketing people want to write jobs, so they didn't really know Bash. Sometimes they copied some scripts and it either worked or not, and we couldn't really expect even from the developers to know deep Linux very deeply. For example, do you know what that little program does? Any ideas? No, or it depends. So if your bin /sh points to bash, then yes, it prints hello world. But otherwise it will fail because usually sh points to dash and it doesn't have pipe fail. And most of our developers didn't know that, and they didn't use proper shebang, so there was a time when we introduced this pipe fail feature and tens of jobs failed. So with time this became a big problem, and a few years ago we used to go to Strata because we thought that we are data scientists, we are data analysts, but then once we went to QCon and we realized that, hey, we have the same problem as these guys, so we are not data scientists but software developers. So we should go software craftsmanship conferences or DevOps conferences because that's where people talk about our problems. So we decided to build a new ETL system, this time not in Bash, but with some normal language, and we picked Go. Go is very easy to learn. It's very nice. It's fast. It's perfect for parallel computation, and we really love it. And yeah, it's much more sophisticated than Bash. So, for example, we could do real test-driven development, which we hadn't done before. So we have Jenkins for that. It was also a new step for us. And we also have an internal deployment system where you can specify the build number from Jenkins, and it only allows you to deploy green builds. So we made it very safe. So we don't want any problems. So we don't want broken code to be deployed. And yeah, that's a big thing because in the Bash ETL system, it worked like every 30 minutes, a cron job pulled the master branch from Git, and that was the deployment. So in case you pushed something half-ready stuff, then it was fired. So it was a bit dangerous. Okay, and as I mentioned, error recovery was a big problem for us. So we designed this system to be very easy to recover. It's great for us because even when these most important so-called core jobs fail that are owned by the data team, we can recover very quickly, and we have a lot of jobs like this. And also it's very helpful for our users, because if they want to re-execute something with all its dependencies, then they can do it with just one command. So it's very popular and people really like it. And we also try to maximize the self-serviciness of the system. This means that we not only have Jenkins and proper deployment for the framework, for the code, but also for the jobs. So if someone wants to write a job, then he or she commits to the master branch, and then Jenkins runs some tests against it. These tests are written by us because we know what are the main problems that can come up when people write jobs. And if it's green, then they can deploy it. So it's not possible to deploy any broken jobs. And we can also let our users know what is the problem. So Jenkins says it explicitly that, oh, you forgot the input, or you wrote the same outputs twice, it must be a problem. So it's really nice. Yes, so that's how we are with our ETL system. Currently, the old legacy ETL and this are running next to each other because the migration is not so easy, because we have more than 400 jobs in the old ETL, and it's not so easy to convince people that you should rewrite your job. No improvement, just rewriting. So it takes some time. But we hope that in a few months, only this bulletproof system will run. Okay, and what our main focus is building a data warehouse. As we already mentioned, earlier we could ask anyone to write a big job, but now a lot of other people, analysts, sales and support people want to look at the data. And they don't want to learn Pig. Pig is kind of painful because it's hard to test, it's slow, so they don't like it, but everyone knows SQL. So we decided to to build a data warehouse and that can understand SQL, and everyone is happy with that. So we tried Redshift. Redshift is Amazon's data warehouse solution, and why we picked it? Because it's very easy to try out. So basically it needs only 2 parameters, your email address and your bank account number, and then you can just fire it up. And actually this probation is not so expensive, it's $100 for 2 weeks, so you can really get a picture of it. It's okay for your goals or not. So that's what we did, and everyone was very happy with that. So we sticked with Redshift. And so it's a massively parallel processing data warehouse. It promises petabyte-scale, and it has Amazon integration, which is really good because all our infrastructure is at Amazon. So it fits perfectly to all our infrastructure. And it's fully managed, so we don't have to be sysadmins again. That's also a very important reason for us. But in the last month, so this story is very recent, we also found its drawbacks, because now the whole company uses it, which means that we had to scale to bigger machines, to more machines, and in this case it's quite expensive. And everyone started to use it, and it turned out when you don't have proper indexes, then it can be really slow. And unfortunately, Amazon allows only 1 index per table, which is not very convenient for our purposes. So it's something we have to solve now, so it's on our short-term roadmap. Okay, so as a short wrap-up, if you remember from 2 things from this presentation, then let it be these 2. First, if you want to scale, you need to do self-service. Or otherwise you have to hire several developers, and probably it will be more painful. And once you do self-service, then you have to be a DevOps guy, or so you have to have a DevOps mindset, otherwise it won't work. Okay, and before the questions, one more thing. Prezi is hiring, so if you find these things interesting, then come to us, talk to us. And not just the data team is hiring, but real DevOps guys are hiring too. So if you're interested, come to us. And what are your questions?
Okay, do you have any questions to Prezi? Okay, one question over here. Sorry.
A question on the security, on the Amazon thing. So what about the sensitive data?
Come again, so the security, Amazon, and what was the question?
Well, it's a more general question actually, but you may have some sensitive data and still it's in the, it's in the cloud. Yeah.
We have most of our data at Amazon, and also in Gmail, and it's just
and
how
it's
it goes.
Like just it, basically.
Yeah, we have a security team who is really checking what's going on, but we believe that Amazon security team or Google security team does a better job in keeping our data secure than our small team.
Okay, thank you.
At least you have agreements on that.
My question is related to moving from Hadoop EMR into Redshift. The advantages that you achieved from Redshift, how much of that was offset in the cost of using Redshift, which is non-trivial, when you get over 10 terabytes of data?
Actually, we haven't moved completely from Hadoop to Redshift.
Oh,
we
so you'll
still
find
have-
out.
Yes, but for interactive analysis, we use Redshift because that's much better for that. We also have a Chart.io integration, but in most cases, people have to prepare the data with Pig, and so we didn't get rid of Hadoop. But
How much data do you currently have in Redshift?
Right now we have around 7 terabytes in Redshift, and that costs us around $1,000 per month. So Redshift is pretty expensive.
Yeah, let me know when you get past 9 terabytes how you feel about
You
that
are there?
cost. Yeah.
Okay, we should talk.
So you're already there. Okay, any other questions?
I'm wondering how you find languages in which you develop the solutions. Why are so marginal ones? Why you not go into Java or .NET?
The question was, how do you find marginal, not popular languages? Why not use .NET or Java or something like that?
okay, so in Prezi, you are free to pick the language that you want to use. And we wanted to try Go because it sounded interesting. It was, so we tried it for a week and it was easy to learn, so we could write a great big amount of code in 1 week, so we decided that well, it's worth it. But otherwise you can usually, if you find a language interesting and you want to learn, then you can just learn, do some small project in it, and spread it around the company.
Yeah.
Specialists which can work with your systems after it is
We don't really like specialists at Prezi. We like people who are like easy to pick up technologies and to go in stuff. So yeah, that's our main. We are working with, I don't know how much, but with like a 20 language in Prezi. And if you join the company, then you are expected to pick up a new language in a few weeks if you need to. Like Haskell. Yeah. Haskell is, who was that? Yeah, we can talk about Haskell. It's one of my biggest trauma in my life. Yeah.
Thank you so much.